Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
Okay, all right, so looks like it is clear. Now, this service mesh is implemented by many solutions, right, to certain degree by console as well. But Istio is by far the most complete implementation of service mesh. Okay, I'm going to clear this slide here. So how Istio works? Well, Istio has two components. Okay, maybe I'll just open Istio's documentation. No, this is not what I'm looking for. The documentation is a little bit of a mess. Yeah, so this is how Istio looks. Hmm? So without a service mesh, you will have, when you have two microservices, for example, the services talk to each other and can talk to other microservices as well. This I have already explained. Yeah. And but when you install Istio or when you start using Istio, your architecture turns into this. You have a service A, service B, but they don't talk to each other directly, right? They talk via a proxy setup here. The proxy is actually implemented using Envoy. Envoy is a different standard to set up your proxies in pods, in Kubernetes pods. So we will talk about that as well, spend some time there as well. But the summary here is that the proxies are set up using Envoy, right? So the communication between the service A and service B is not direct, but it is via these Envoy proxies. And these proxies will capture all the network related data, for example, the response times, the logs, telemetry data, for example, which service or which function is called so many times, which user is accessing which functions or which features the most. All that telemetry data is captured here in this proxy and it is sent to the Istio control plane. So Istio control plane is nothing but a set of configuration, set of features which actually make sense of the data that is generated by your proxy, right? So proxy captures some data from the network and the control plane makes sense of that data, maybe do some visualization, display it nicely for the users, parse that data to store it in defined formats and things like that. All right. And the configurations of these proxies, right? What data to capture, how frequently to capture, and all that configuration is also um, defined in the control plane, and the control plane will ensure that all the proxies have this configuration applied to them. Okay, so the proxies are automatically added to the pods by this control plane, and the complete configuration of this proxy is also governed in this control plane. And the data that is captured by the proxy is sent back to this control plane. Okay, so this is the control plane where the brains of service mesh exists, and this becomes the data plane, right? The data plane component of a service mesh, which consists of these proxies, which actually is responsible to capture the data of the network. Okay, so the data plane intercepts the network, captures the data, and then sends all the required data to the control plane. Right? Make sense?
Yeah, makes sense. So Envoy is the proxy that's really the main engine of the data plane, and then Istio controls the the engine from the control plane.
Exactly. Exactly. Yes. So it's like having a car. So the actual work in the car. So what is the purpose of a car or any automobile is to take you from point A to point B. And the actual work is done by the wheels, right? Unless you have wheels in your car, you cannot move forward. But the power given to the wheels or the control given to the wheels comes from the engine, right? So the
Right.
Envoy proxy are your wheels who are doing the actual work, but the configurations, the where to go, how fast to move, that all information is coming from this engine that is Istio control plane,
Okay.
right? So there are many things that Istio does. For example, first is traffic management. Okay, so that means it routes the traffic between services, something similar to console, right? It has information about where the microservices are running, what is their configuration, and also it can split the traffic between two different versions of microservices. For example, what do I mean here? I mean that, okay, I should not have deleted that slide here, but let's say you have your payment service, for example, right? And it talks to the order service here, right? And let's say the order service is of this microservice is version 2.0, right? And you want to release this order microservice version 3.0. Okay, and how do you release it? Right? So you will develop microservices order version 3.0 and you do a lot of testing on them, right? You do a lot of testing on the microservice, but still some bugs may slip in, right? So you are never sure if your new microservice is free of bugs or not, because always there will be some bug. So generally what will happen is you will test your version 3.0 of your microservice, and then you uninstall or remove the older version of microservice, deploy a newer version, order version 3.0 of microservice, and the payment microservice will talk to it, right? But if this has bugs, then your payment system will be broken because it may receive some erroneous data from the order microservice, right? And the payment system itself may fail, and this may be a huge loss to your organization and a huge disappointment to the customers, to the end users. So you do not want to actually set things up like this or release like this. What you want to do is you want to do a canary development. So what does that mean? That means along with your older version of your microservice, you deploy the new version of microservice, order version 3.0, right? So you deploy both microservices and then you split the traffic coming from the payment microservice to the order microservices. You say that 90% of my traffic will go to the previous release or the current release, and the remaining 10% of the traffic goes to my new version of the microservice, so that you can observe this behavior. If some error is happening, then only 10% of the users are impacted and only 10% of the transactions will fail or whatever, instead of all the transactions failing. So you can observe the behavior of the new version of microservices by just using it for 10% of your transactions. And once you are satisfied that there are no bugs and no critical impact of this new version, then you slowly increase the traffic, increase the share of the traffic, and slowly reach to 100% here and 0% here. And then at the end, remove this. Right? So the service mesh makes it very easy to do canary deployments as well, because you can configure to which microservices the request should be redirected, right? So it allows you to perform some traffic management. It allows you to perform or have observability on your network, right? So Istio generates detailed telemetry for all communications within service mesh, because it captures all the network going from point A to point B in the service mesh. It captures all the data points of that network flow. When was it started? When did it reach the endpoint? How much time it took? Uh, what was the result given back from the microservice? Was it HTTP error code 200, which is success, or 401 that it was unauthorized, or 500 that it is unavailable, or what was the result of the network? And all that data is sent to the control plane for your administrators or the developers to consume, right? And because we have a separate data plane, we can configure all this observability in that data plane without requiring the application code to be changed. Yeah, so that's there as well. Then, as I said, all the microservices are designed to talk over HTTP. All the microservices talk over HTTP. So it's a plain text communication. If somebody gets into your cluster, well, apart from many other bigger problems, one problem will be that the user can intercept the traffic happening between microservices, and the traffic is unsecure, so any sensitive data can be extracted from the traffic interception, right? So to avoid that, because we have these proxies in middle, I will go to this slide here. Because we have these proxies uh, intercepting the traffic, we can also use them to add a little bit of encryption on this communication. So as soon as your pod sends a HTTP request to the external or service, well, proxy will intercept the traffic and add a little bit of encryption on top of it, right? So it will convert this HTTP request to HTTPS and then forwards it. The proxy will receive HTTPS request. It will understand this HTTPS request, and then internally, then after this, it will forward it as an HTTP request to the application. So although the application is still using HTTP and HTTP, but the communication is happening over HTTPS, the inter process or interpod communication, right? So that is also implemented by uh, by service mesh, by Istio, right? How to work with HTTPS, what should be the certificate authority used, what should be the certificate used, all that configuration is pushed to the proxies from the control plane, right? So which is the HTTPS certificate that should be used? How do you trust a certificate? Which certificates to trust, which certificates to not trust? All that configuration is pushed to the proxies from the control plane. Make sense?
Yeah. Yeah.
Okay. Then now we know what is this service mesh, how does it work. Let's also see how we can install it. Okay, how we can install this service mesh. Now the simplest installation of service mesh is within one cluster. So you have one Kubernetes cluster and you have multiple applications running, multiple pods running, or multiple services running in the cluster. You can bring all of them together by running one control plane, right? The example that we have seen till now. So you have service A running, service B running, you add your Envoy proxies here, and the control plane can manage all the traffic, right? But things get complicated when you have multiple clusters, right? How do you deal with that in multiple clusters? So you can have multiple clusters here. For example, you can see there are two networks here. There is this network inside this black box. Maybe I'll open it in a new tab. Yes. So there are two networks here depicted by these black boxes. So there is a network east, there is a network west, and in this network there are two clusters, right? So cluster 1, cluster 2, and then there is another network or another cluster running on another network, right? And there are microservices running all the places, similar microservices. So it's kind of a high available setup. You have same set of applications running in multiple clusters. Well, you can still have a single control plane, but can have multiple data planes spread across the cluster. So each cluster will have its own data plane here. You can see this is one data plane, this is one data plane, this is one data plane, and then all of them will be governed by one single control plane. So you can set up your um, Istio setup like this, right? This also gives Istio a way to achieve high availability. For example, if this cluster goes down, there is still cluster 1 available, which can take care of serving the requests, right? So this is multiple servers, multiple clusters, right? Then there are ways to handle multiple networks as well. Then there are ways to handle how many control planes you want. Do you want a single control plane for multiple clusters, or do you want multiple control planes for each of those clusters here, right? So different topologies and all supported by Istio. So there are various deployment models. Okay, so in the next session, when we talk about hands-on of Istio, when we will install Istio and see it in action, we are going to keep it simple and we are going to work with a single control plane, single service mesh in a single cluster. Okay, so we will set up a Kubernetes cluster. You guys know how to set up a Kubernetes cluster now, so we'll set up that, and then we will use that cluster to set up um, our service mesh infrastructure, right? I will also show you a detailed architecture here of Istio. So when you install Istio, it becomes something like this, right? So you have services, and then you have your data plane. The green one is the data plane, and the blue one is the control plane, right? In the control plane, you can see there is something called as Istio D. Okay, so Istio D is the binary or is the heart of your service mesh. So control plane is essentially just one binary, which is Istio D. The data plane is based on Envoy proxies, right? Istio D has a lot of features. For example, it has pilot to um, okay, in the previous versions of Istio, there used to be, instead of just one Istio D, there used to be multiple applications like Pilot, Citadel, and Gallery. But right now, they don't exist anymore. Everything is just in single binary Istio D, and which takes care of maintaining your traffic and observability and SSL or secure communications. Right. So in the next session, we will also talk about Envoy. How do we use Envoy, and how Envoy proxies are installed on the microservices, how we use sidecar topology in the pod to install proxy, also how we can configure Istio to automatically inject Envoy proxy whenever a new pod is created, right? So we don't want to manually write our deployment files or our pod manifest files to have two pods here. We will just write our pod definition files with single service here. But Istio, when we will deploy this pod, Istio will automatically inject a proxy sidecar here. We will see how that is done as well.
So
Yeah.
Istio is like a binary but Envoy, like, is that a binary too, or that's something different?
So Envoy is also a binary because this pod is going to use an image here, a Docker image, which
Hmm.
is provided by Envoy. But that binary implements certain set of APIs.
Okay.
Okay, and those APIs are implemented in that Envoy binary itself. Now, those APIs enable the communication between control plane and proxy, right? So the control plane can talk to this proxy by using those APIs and getting all the data. So we will see how that communication also works, right? So we will also talk about Envoy in detail, um, how Envoy proxy works and what does it do. Okay, so that's all I wanted to cover today. And in the next session, we will install Istio. So if you want to do something beforehand, right, like installing Istio and stuff, you can go to Istio's documentation and go to setup and then install Istio just like that. Right, so you can install Istio um, and explore. I'm also going to use the same documentation for our demonstration. I don't have anything specific created by myself, so I will also use the same documentation. All right. So yeah, any questions before we wrap up this discussion?
Okay, so yeah, so Istio is binaries, but would we use if we were to do this, would we use Minikube, or how would we how would we do it if we were to do it ourselves?
So you can use Minikube,
Mm-hmm.
yeah, to bring up a cluster just like that in your own machine.
Mm-hmm.
You can also use, or you can create a complete cluster like I demonstrated using kubeadm. You can also create your own cluster on Google Cloud Google Kubernetes Engine or AWS EKS or any other cloud provider. It does not matter where you create this. Yeah, you can also use Docker Desktop to create a cluster on your own machine here. Right? The only thing is that the Kubernetes version, wherever you deploy this, the Kubernetes version should be starting from 1.19 to 1.22.
Okay.
For the older Kubernetes version, this may not work.
Okay.
Yeah. But yeah, it requires these resources. So on your laptop, if you are setting up Minikube or using Docker Kubernetes, then you need to at least have 8 GB of RAM allocated to Docker and 4 CPUs, because this is going to, Istio is going to add a lot of load on the cluster.
Okay.
Yeah, you can see here, if Minikube as well, then yeah, here actually it is allocating 16 GBs, but I don't think you need 16 GBs here. 8 GBs is sufficient.
Thanks for watching. Want to study further? Join our training programs today.